Namaste everyone, it's me Shailendra. Welcome you to online monastic classes. In previous class, we have discussed about theoretical parts of shape. Today we will learn which type of formula will be utilized in this chapter and how to draw the Venn diagram. First of all, starting with how to draw the Venn diagram, then we will learn how to remember the formula or how to form a formula. Let's start today's class. First of all, how to draw a Venn diagram. Let's start with an example. If it is given A is factor of 6, you know that factor means the number which will exactly divide this, that is 1, 2, 3 and 6. If we take multiples of 3 less than 20. When we say multiple, that is the number which will be multiplied by 3. They are 3, 6, 9, 12, 15 and 18. If we have to show these two relations, these two sets in a Venn diagram, the first of all we have to know either these two are overlapping or disjoint or subset. Here we can see common elements are there. So it's a overlapping sets. So when they are overlapping set, we have to draw a Venn diagram like this. That's A, that's B. When we have to write the elements inside it, we will always start with the common parts. So what's the common in these two? They are 3 and 6. Now look in A. Already we have written 3 and 6. What are the remaining elements? 1 and 2. Now in B already we have written 3 and 6. What are the remaining elements? 9, 12, 15, 18. That's we have drawn the Venn diagram. But if it is said to represent A union B in a Venn diagram, we have to draw the same Venn diagram, but we have to save this. When we say union, it means all. All means whole A and B. If we save this represent A union B. This whole represent A union B. If we have to show only the intersection, then we have to save these parts. Only A, that's only A, that's only B. If universal is given, suppose we have universal from 1, 2, 3 up to 20. So when we have to draw the universal, we must have to take a rectangular area like this. We have to draw a rectangle. And now what are the remaining elements which are not in A and B that will be written outside? That is, first of all, what are the remaining elements? The remaining elements are, we have written 1, 2, 3, 4, 5 is remaining, 6 is there, so 7, 8 is remaining, 9 is here, so 10, 11, 12 is here, so 13, 14, 16, 17, 19, 20. We have to write all these outside the A and B. Outside which come A and B, that is A union B complement. This outside all the elements are A union B complement. To draw a Venn diagram with the given information, we'll always start with writing from the intersection, then in only A or only B, and what the rest lies in universal should be written outside. If we look, A is 3, 6, 9, 12, 15, and B is 1, 2, 4, 6, 12. Two sets are given. We have to find first A and union B, and we have to show it in Venn diagram. To find this, we have to write these elements. Then you know union means whole. That is starting with 1, 2, 3, 4, 6, 9, 12, 15. We have learned union of A and B means all the elements of A or B or both. Now, to draw the Venn diagram, you have learned we have to start always from the intersection which is common in both. So what are the common elements in these two? 1 is not common, 2 is not, 4 is not, but 6 and 12 are. Right, 6 and 12. Now what's the remaining parts in A? The remaining elements in A are 3, 9 and 15. What are the remaining elements in set B? That is 1, 2, 4. If we are showing A union B, say it like this and write below A union B. Not necessary when only we are talking about A and B, we must have to draw this rectangular area. Rectangle inside universal will be shown. But if you have done, that's correct, that's not the wrong, but not compulsory. But when universal is given, we must have to draw that rectangle, and inside the rectangle we have to show the sets which is given there. Now move to 3 sets. If A is 1, 3, 6, 9, B is 1, 2, 4, 8, and C is 1, 3, 9. If we have to show this in Venn diagram, the first of all we have to find A union B union C. We have written all the elements of A, B and C. For the union, we have to take all of these. Generally, we write in arranged way, but not necessary. 1, 2, 3, 4, 6, 8, 9. Now, when we have to draw the Venn diagram of this relation, A, B and C, what we have learned, we will start from the common parts. The first of all, we will see either there is any element which is in all these 3, then we can say one is the common in all the three. After 1, no other are in the common elements in all these sets. Then what we have to look, what are the common elements in A and B? There is no common element, so there we don't have to write anything there. Then we have to look common elements in B and C. Only 1 are there, so we don't have to write anything there. Then in A and C, here 3 and 9 is the common element. Now, after writing all these, we have to write in only A. That's the whole circle represent the set A. So far in the circle A, we have written 1, 3 and 9. What's the remaining elements? 6. So write 6 there. In B, we have written only 1. That circle represents the set B. Remaining elements are 2, 4 and 8. In C, 1, 3 and 9 all are written there, so we don't have to write there. If we said this whole represent A union B union C. Now, when we have to find the intersection and we have to show it in Venn diagram, 2, 4, 6, 8, 10 and B 3, 6, 9, 10. There are 2 sets given. First of all, we have to find the intersection and we have to show this in Venn diagram. Then first of all, we will find the intersection. You know, intersection means the common parts. What are the common elements? Here, common elements are 6 and 10. So, intersection of A and B is 6 and 10. Drawing the Venn diagram will be not changed, but shaded region will be changed. We have learned if there is a overlapping set, how to draw the Venn diagram. Now we can write here common parts 6, 10. Then what are the remaining elements? 2, 4, 8. And in set B, what are the remaining elements? 3 and 9. These parts represent intersection. We can write A intersection B. We have already said it, so not necessary because shaded region is there, or you can show this. The Venn diagram in all the condition will be same, but shaded region will be different according to the given question. But when you have disjoint set, like A is given 2, 3, 4, B is given 5, 6, 7. If we have to show this in Venn diagram, then what to do? That's A, that's B. Since there is no common element, we have to write separately. That's it. Then we have learned 2 more operations, that is complement and difference. A difference B. If we have to find this, 2 set A and B are given. A difference B means all the elements in set A which is not in B. So what are the common elements in these 2? What's the remaining elements here? That's the A minus B, or difference of A and B. Same way, if we write B minus A, 1, 2, 3, 5, minus 3, 5, 6, 7. Cancel the common elements. What's the remaining on B? That is 1, 2. This represent B minus A, or difference of set B and A. If we have to show this relation in Venn diagram, as you know, we have to start from the intersection, that is 3 and 5. Remaining element 6, 7. In B it is 1, 2. This part, this represent A minus B, and this part represent B minus A. Moving further, if we have universal given from 1 to 10 and set A is given 3, 5, 7, 9, and we have to find A complement of set A. You know that A complement means universal minus A. That is 1, 2, 3 up to 10 minus 3, 5, 7 and 9. When we do the subtract, these parts will be left from this all. From 1 to 10 we have to leave 3, 5, 7 and 9. Remaining elements are 1, 2, 4, 6, 8, 10. When we have to show this relation in Venn diagram, that's the set A. It is 3, 5, 7, 9. Outside it is 1, 2, 4, 6, 8, 10. And outer part will be shaded. This will represent a complement. Now come to the formula. These are the basic things which already the class 9, 10 student knows, because these things you have completed in class 6, 7, 8 all. Now we will start formula of this exercise. First of all, we will draw a Venn diagram. A and that set B. If I write these things, what you can see in the figure, this part X represent number of only A. This part represent number of only B. And this is the common part, that is number of A intersection V. And this is, that is outside the A and B, this represent A union B complement. This is number of A intersection B. This is number of only A. This is number of only B. And this represent number of A union B. When we say number of A, it means sum of these two, that is X plus Y. Number of B, that is Y plus Z. Now let's start. We have to write the formula of number of A union B. From Venn diagram, we have in A and B, what are the number there? They are X plus Y plus Z. So what does X represent? Number of only A. Y represent number of only B, a number of A intersection B. and Z represent number of only B. So we have first formula of union, number of only A plus number of only B plus number of A intersection B. That's the first formula we have for number of A union B. Next, again we have number of A union B x plus y plus z. If I write this in this way, x plus y plus y plus z, but I have written x plus y and y plus z. So when you do the simplify, sum of these two, here came 2y, but we have only 1. So if we subtract minus y, then these two are equal. Now, what does this represent? Number of A. What does y plus z represent? Number of B. And what does y represent? Number of A intersection B. So we have second formula, number of A union B is number of A plus number of B minus number of A intersection B. When you look in the Venn diagram, number of A, this is whole, number of B is this whole. So when we take number of A plus number of B, this part 2 times it counted. So we have to subtract once. That's why we have the formula number of A plus number of B minus number of A intersection B. Now, in this again we can write this as x plus y plus z. We have grouped this. What does x plus y represent? Number of A, and z represent number of only B. So we have third formula of number of A union B is number of A plus number of only B. We can write number of A union B in this way also. What is this? Y plus z and x. We have grouped now y plus z. So what does x represent for us? Number of only A. Y plus z represent number of B. So we have fourth formula, number of A union B is number of A plus number of only A plus number of B. Here it is number of A plus number of only B. Here it is changes number of only A plus number of B. So we have written so far 4 formulas. Again, here you have x plus y plus z. In this figure, x plus y plus z plus p represent number of universal. This whole is number of universal. If I write x plus y plus z plus p, here came p plus, but here is not, so it will be minus p. So here look this x plus y plus z plus p, this whole represent number of universal minus P is number of A union B complement. So we have the fifth formula, number of A union B is number of universal minus number of A union B. So we have written the formula of number of A union B. First formula came number of only A plus number of only B plus number of A intersection B. Second one came number of A plus number of B minus number of A intersection B. Third one came number of only A plus number of B. Fourth one came number of A plus number of only B. And fifth one, number of invertial minus number of A union B complement. Now, for the intersection formula, if we solve this calculation, if we solve this formula, we have to change the side of this. So we can write number of A intersection B is number of A union B minus number of only A minus number of only B. Same way, if we solve this formula, that is number of A plus number of B minus number of A union B. Three number of A union B complement. If we simplify this one, this side will change, then it will become plus, and this side will change, then it will become minus. So we have formula of number of invertial minus number of A union B complement. And you simply know from the figure, that is A here union, whole minus union, that is universal, minus union is complement. For universal, from here, if we change the side, union plus union complement. Not only union plus union complement, whatever we are writing and its complement, like number of A plus number of A complement, number of B plus number of B complement, number of A intersection B plus number of A intersection B complement. Number of only A. From A, if we subtract the common parts, it came number of only A. Then, from the union, if we subtract this B whole, that is number of A union B minus number of B. Number of only B, same way, number of B minus number of A intersection B, and number of A union B minus number of A. Number of only A plus number of only B. Number of only A plus number of only B, that will be the sum of these two. So when you do the simplify, what you are getting? Number of A plus number of B minus 2 times number of A intersection B. Simply we can say this whole, that is union, minus number of A intersection B. Number of A is number of only A plus number of A intersection B, or number of A union B minus number of only B. This whole minus only B will be number of A. Then also number of universal minus number of B complement. Now we have to note two things. When A and B are disjoint sets. When A and B are disjoint sets, it means number of A intersection B is equal to 0. Then now, whatever the formula we have, if we write number of A intersection B equals 0, what's the new thing is coming? That will be our formula. Like we have number of A union B equal number of A plus number of B minus number of A intersection B. If we put this value 0, it came number of A plus number of B minus 0, that is number of A plus number of B. In this way, wherever intersection came, in place of that, if we write 0, we will get the formula when A and B are disjoint sets. Again, when A is subset of B, you know the meaning of subsets? When I say A is the subset of B, it means this A lies inside the B. So what will be the common between these two? Common between these two will be this. So when A is subset of B, number of A intersection B is number of A. And if we use this, then we will get the another formula. Suppose if we have to write an A union B formula, the number of A plus number of B minus number of A intersection B. So what is the number of A intersection B we have? Number of A. If we put this, cancelled number of B, and you know from the figure this whole is B. So number of A union B is number of B. So when it is subset, when A is subset of B, number of A intersection B is equal to an A, and number of A union B is equal to number of B. That is, which is the subset, that came intersection, and what is the superset, that is the union for us. These are the formulas for when A and B are subsets of universal set. Only two sets are subset of universal. In class 10, we have to learn when three sets are given, A union B union C. So when we have three sets given, how can we find the formula of union? Now look this figure. A, B, C. What is this common part name? This is number of A intersection B intersection C. What's these parts only? Only up to these parts, that is only A intersection B. Same with these parts only up to this, only A intersection C. These parts only B intersection C. This part is only A, this part is only B, this part is only C. Then If we say this whole is number of A intersection B. This whole number of A intersection C. This whole number of B intersection C. This only A, number of only B, number of only C. This whole circle represent number of A. This whole circle represent number of B. This whole circle represent number of C. And the number which will be outside this, that will represent A union B union C complement, and whole these represent universal.